Have you ever wondered what the universe sounds like? I know, sound doesn't exist in space because there's no air for sound waves to move through. But there are signals we can translate into audio form. So what if we've replaced our ears with more sensitive instruments? Let's start close to home. Thousands of kilometers above Earth's surface sit two rings of charged particles called the Van Allen radiation belts. Disturbances in the radiation belts create the radio waves known as chorus. We can detect chorus on Earth, but NASA's radiation belt storm probes, launched in 2012, are much closer to the belts, which help them nab this incredibly clear recording. Chorus isn't the only sound in our solar system. The sun also makes a lot of noise. Bursts of energy called solar flares produce radio signals that reach Earth. Here's a flare signal recorded earlier this year by amateur astronomer Thomas Ashcraft. And what about coronal mass ejection? Massive amounts of charged particles that go flying off the sun at 200 to 1,000 kilometers per second. As these particles ping into spacecraft and other orbiting instruments, they pick up a signal that sounds like this. Another way to listen to the universe is to turn visuals into audio. For example, the twinkle of distant stars can be translated from light waves to sound waves. Take a listen. Based on a star's music, researchers can calculate its size and speed of rotation. And if we want to know what the early universe sounded like, we've got the Planck Space Observatory, which created the most accurate map ever of the light left over from the Big Bang, known as the cosmic microwave background. Physicist John Cramer of the University of Washington turned all that data into audio files. These clips compress the first 760,000 years of the universe into seconds. You can hear the intensity of the cosmic microwave background increasing and decreasing. As the universe expands and stretches, the pitch gets lower and lower. So as you can see, here, even without sound waves, our universe is a pretty noisy place. For Scientific American's Instant Egghead, I'm Sophie Bushwick.